Okay, so we're back going through another demo. This time we've chosen, we are in the Amazon Bedrock Agentcore samples repository. We have our PyCharm running, our virtual environment at the top level here, Amazon Bedrock Agentcore samples, and we have tutorials we're looking at. This one is under the runtime, Agentcore runtime folder, and it is hosting agent to agent. So we're going to look at what this means and what we can learn on how to have an orchestrating agent talk to different agents that specialize in different things. So it's pretty straightforward. Now, I just want to tell you that as simple as this is in the code, Bedrock does this automatically for you with the console. So just keep that in mind. Okay, so what does it say? The A2A protocol is an open standard designed to facilitate communication and interoperability between independent and potentially opaque AI agent systems. In an ecosystem where the agents might be built using different frameworks, languages, or by different vendors, A2A provides a common language for interaction. I just went through this demo. The only thing I saw here which was interesting is that this agent here is built with and kind of registered with an A2A server. This agent here is built and registered with an A2A server, and this A2A client, the orchestration agent, seems to be calling that server to talk to these things. So keep an eye on that, and basically, yeah. I think what I'm doing now is I'm just focusing on this one orchestration agent talking to different specialized agents, either in parallel or sequentially. It doesn't matter. And there's always an LLM involved to help the communication. And the user is asking a question to the orchestration agent, who can be passing it to a particular specialized agent. So that's the goal of this. So they're saying that A2A support for Agentcore runtime was recently created. In this workshop, you're going to build the following architecture using the Agentcore runtime. Now, there's a little box around this, and I'm in the Jupyter Notebook for this first 01 notebook. It's a sequence of Python code which generates the two separate agents, and then the other notebook creates the orchestration agent, and then we have a third notebook which cleans up. And I just ran this cleanup. I'm going to see if it works. So if we have any problems with this, that would be one of the problems, is that the resources still exist on Amazon. Okay, so anyway, the point is the user is asking a question. The orchestration agent is an A2A client, and it talks to where it needs to talk to. If the user asks for something relative to docs, it talks to the docs agent. If it needs something related to blogs, it talks to the blog agent. And of course, these agents use MCP to talk to its tools. So there's some things there. Okay, so first what they want to do in this notebook is create the two agents, these two. And the first agent is an AWS Docs expert, and it reads the AWS documentation, generates recommendations. So first we need to install our dependencies. So I'm going to click this, and you notice this install. It's going to take a while because it's using the requirement. It's doing a force reinstall, and it's also saying no cache. So it's clearing out the caches, and basically it will take a long. Now, meanwhile, while we're looking at this, keep in mind that there's some tools here. We're using DuckDuckGo Search API here to search for AWS blogs and news. Okay, so the other thing is if you look on the left, let me keep this up here just to keep an eye on it. So if you look on the left here, you'll see that we have this directory we're working in, and we're working with this Jupyter Notebook. We're in PyCharm. We have a virtual Python environment. And notice this install has a percentage, and this one has a bang. And all the other demos I went through had a bang. So what I noticed is that in PyCharm you do have preferences, and this development environment in Python is using a virtual environment. And that thing is pointing to, the IDE right now is pointing to all these packages that are installed, all these versions, and I could go and dynamically upgrade them if I want to, which at the moment this install is removing, uncaching, and reinstalling and doing whatever I want, so I don't want to mess around with that. But the point is that this bang is a little bit different because it's assuming that it's not, it could be pointing to a different Python environment, but the way I look at it is my command line is using the same virtual environment. So I went into this directory here, and the virtual environment I'm using is pointing to this one, and it started running the startup for the virtual environment here. That's why my prompt actually says that. So I'm hoping that there's really, these things are compatible whatever they're doing. But I have been using this pound pip for a while now in the other demos, and for some reason this one is using the percent. And in general, this one is supposed to be more precise using the virtual environment that the project is running in, that the notebook is running in. Oh, well, here, let me rephrase it. The kernel for the Jupyter Notebook is using a runtime environment, and I'm hoping it's this one here because this is pointing to it. I was assuming that the whole time. I just don't know much about the Jupyter Notebook and how, when it starts running, how it determines its virtual environment. But if there's any compatibility issues or anything like that, keep an eye on it. Okay, let's just see what this is. This is commented out, but this does shut down the virtual environment. And usually what I do is I look down here and see what it's doing. When I click on this install, it shows down here that I'm starting up the kernel. So up here there's an icon to clean the outputs. Over here there's a shutdown of a cell that's running, and here is restarting the kernel. So usually I do some combination of that, but if everything works, I don't really I get too hung up on it unless there's a problem. Before this thing checks off, which it should soon, I want to look at this next cell. It does a pip freeze and it greps on Bodo. Basically what we're doing is we're showing you what versions of Bodo libraries we're using and what versions of Agentcore we're using. And so those will show us that information, and we want to make sure. Now this install is using the requirements text. So, okay, so I got a bunch of incompatibility errors, which, like I said, I want to ignore because most of them are open telemetry. Let's see if there's anything here I'm concerned about. Oh, it's over anyway. But let's take a look to see if there's anything concerning here. Well, this is a little bit concerning, but the bottom line is, you may need to restart the kernel to update the packages. But I just did this a minute ago, so I'm not going to do that. Let's go over here and see what this output cell gives me. Now, notice the open telemetry. It says what I'm using. It might be incompatible with what it needs, but right now I'm focusing on the Boto 3 and the Agentcore and the toolkit. Now let's look at the requirements doc. It says Boto has V1.4, Agentcore 0.1, and starter toolkit 0.1.4. Okay, so it just showed me what I was using. Now we're going to start a Boto session. The reason why I'm not using default session is because I'm using the West region and a certain account, and I just want to be precise enough in case I need to do the same thing again. I don't know what this is doing. Oh, it's making the directory. Oh my God, it made a directory agents. So my agents will get written into this folder. They were just there a minute ago, and this kind of deleted them and make the directory again. So here it is. So now what I'm going to do is I'm going to write a first agent code to a file locally. So this describes the file. A checkbox says it was written. You don't see it show up, but it's available. It'll show up eventually. But anyway, it wrote it to this agents directory. Okay, it will show up eventually. Sometimes I go to find something in this folder and eventually it shows up. But let's move on. Okay. So what did this thing do? What this thing should have done is wrote a file, a Python file, which is an agent. It's an AWS Docs agent. So it is really this guy over here. This is the code, the Python code that's going to have the Strands agent where we can talk to it. Okay, and all we did was write the file. We don't have the code deployed anywhere, or we're not running it anywhere right now. But let's take a look at it. Okay, so the first thing you have to notice is that this thing uses an A2A server. So what I find interesting about this is that this agent is built so that the A2A server can talk to it. So the client orchestration agent is going to talk to this thing. And it seems like it's using some tools. It's using Fast API. And it's setting up a logger and using OS. It gets the Agentcore runtime URL. Okay, so this is a function which gets the MCP client, and it looks like it's pointing to an AWS Labs documentation MCP server. That's what it looks like. Okay, so start the client. Now we didn't run this thing yet. I'm just looking at it. Okay, client initialization, timeout, errors, system prompt. You are an AWS documentation assistant powered by the AWS documentation MCP server. Your role is to help users find accurate, up-to-date information from AWS. So, this is what we're doing. We're using an existing MCP server, and it is an AWS documentation MCP server. So keep that in mind. Keep the responses short and focused so we don't pay that much for tokens and we can deal with the response. Provide concise, actionable answers. 3-sentence. Use bullet points for lists. These are instructions, okay? When you could evaluate the agent with instructions by evaluating this agent, and you'll see that it's either listening to instructions or it's not listening to instructions at certain levels. So it says skip verbose. If MCP is unavailable, provide basic AWS knowledge. Timeout operations. If 8 seconds, prioritize speed over completeness. Okay, you have access to AWS documentation. Search tools when available. What are those? Those listed tools. Let's go back up here. There's tools. Read documentation, search documentation, recommended documentation, get available services. So I'm assuming those tools are there. What else? Now we instantiate the agent. We put in the system prompt. Start with no tools and add the tools dynamically. There's the name, AWS Doc Agent, an agent to query AWS Docs using AWS MCP. Okay, so this is a function. Here we're we instantiate the agent. This function sets up the agent tools. We call MCP and we list the tools, and agent.tools equals tools. Okay, and then we have this A2A server that we instantiate. It takes an agent, a runtime URL, and it serves that route. So now let's see. Here's a get ping. This is our ping. Here's an app startup event. And notice there's this little mount, app.mount. So remember the app. The app is the fast API. We're mounting the A2A server to the fast API underscore app. It's kind of relatively simple, but you lose track of what you're doing if you, because the variable identifiers. Okay, so this is a function to set up the tools. These are a ping, way to ping for the status. This is a startup, the way to start up. App startup, then app mount. Okay, so now we're running the app on the host and the port. So we just wrote this file. We let's say we didn't run it. You could run it now. You could run it on the command line. You could run it different ways. But let's do this. Okay, so this could run the code locally. So if we ran it down here, we could run this locally. We could start it locally by making a curl call and using JSON RCP. It will query MCP and then return the answer. Let's just take a look at this for the moment. And you could also use test the agent card information retrieval. So you can call this and get the agent card. Okay, so let's instead of doing that right now because I might make a mess of it, let's move on. And it says now let's write our second agent. So we execute this. This is the blogs news agent. Once again, it imports the A2A server, uses fast API, and it uses the DuckDuck search. And basically, it configures your log. It has the runtime URL, Agentcore runtime URL. Now here's the function. Now that this is annotated as a tool, you've got a fast internet search. This takes the string, maximum results, etc. So if you look at this, it's using the DuckDuck to do the searches, the text searches. And it's giving back the formatted results. And there's exceptions here that are caught. Here's the system prompt. You're an AWS blog expert. And here's the guidelines. So the system prompt is all of this. Now it's saying, keep responses short and smart. Provide me with 3 recent results. Focus on official AWS blog post only. Use concise summaries, 1 or 2 sentences. Include direct links when available. Timeout searches after 8 seconds. If search fails, acknowledge the limitation. And the LLM could do a best guess if it wants, so I don't know what we're instructing as. Search strategy, always include AWS in searches. Focus on these blogs' content. Prioritize recent announcements. So we're basically telling the agent what to do. We're creating the agent, creating the systems. We define the tools. We use the system prompt, we define the tools. We give a name to the agent. We just give it a description. And now we put that agent in the A2A server. So this is a key step here. And like I said, if you're using a console and you're just creating an agent, a multi-agent system interactively, this is probably being generated on the scenes. But this can happen without coding. That's what I'm saying. Runtime URL. Server at root. Here's my app. Here's my ping app. Here's my app mount. A2A server to fast API app. And then we're running the app here. Okay, so we just wrote that endpoint Python script here. And once again, it's still not showing up. Let's continue. This writes a new requirements file. It doesn't seem to put the tools in here, the starter tools. So I don't know why they're doing this, but it rewrote the requirements. And now let's deploy the solution to agent runtime. Before we deploy agents, we have to set up a Cognito user pool. So we execute this. And we have our discovery URL, our pool ID, and our client ID. So we're good to go. Who's using that? Okay, think about that for a second. Let's look and see what else is next. Create an IAM role for the agents. So this Cognito pool seems to be, okay, the customer's talking to the orchestration agent. The orchestration agent is talking to the AWS Docs agent. So there could be different levels of security there. And usually the Cognito is a client that's talking to, let's say, the orchestration agent. And usually somewhere behind the scenes, the Cognito could be used, or an IAM role could be used. So within AWS, we typically use a role. Let's see what this is. AWS Docs role. So this is the role for the AWS Docs. It's an execution role for the Docs agent. Here's the blogs role. We created that. So now we need to start a toolkit from Agentcore that can deploy the AI agents to Agentcore runtime. Now notice we're still not using the orchestration agent here. We just got these two agents, and we're going to throw them. We will now create an agent with the support for A2A protocol inside Agentcore. Let's configure and deploy the first agent. Boom. Okay, so notice this code here ran, and what it did was it pointed to the Strands agent. The agent. It should be under here, but let's not worry about it right now. And it's using the execution role, and it's using a requirements file, etc. And the authorization is configured with Cognito, and the protocol is A2A. Okay, so let's see what this says. This says that the Docker is not found. So what it does is it starts generating what's needed, right? It starts generating, notice agent to agent, the Docker file and stuff, and it knows the account and the region and blah, blah, blah. So let's launch this thing. So what it did was it looked in the registry. It didn't find what it needed for the Docker container. So it started deploying the Docker container in the registry, and now it's going to run the pipeline to deploy the Docker file to a particular image. And let's just see what happens here. Now it's still running. Now the Docker file and everything should be generated over here. I'm going to try to figure out why by doing a find. Let's do this. I used to be able to refresh this, and with Node.js I could refresh this. Let's do this. So what I do is I'm going to say Strands. This is really the one I'm looking for, right? So let me strands underscore AWS. Okay, I'm not gonna worry about it right now because it's problematic probably in my PyCharm. Okay, so yeah, where were we? Execution roles. Okay, let's move forward. We did the launch. Launch complete. We want to find the status. The status is ready. This is the AWS docs. And now we want to configure the blogs and news agent. Do a launch. Now at this point I'm on the blog agent, so you know it could be overwriting the files to deploy the Docker image, whatever. I don't know exactly what it's doing, but typically if the Docker files, I just looked at Docker file after I ran this program. It had everything in it. So it had the two agents and the orchestrator agent. The YAML configs had everything. So by the time you wind up doing the second orchestration, you wind up with all the files there, which have all the configurations there. But some of the folders do rewrite the Docker file when it needs to, but I don't know what's happening because I can't see the Docker file in the directory yet. But the two agents were already written here, and I don't see them. So, but they are accessible. Okay, then what it's going to do is going to check to see if the blog agent is running, it's ready. Yeah, now remember very quickly that each agent's running in the Agentcore. It could have its own runtime, it could share a runtime, but right now it looks from the diagram it looks like there's two Agentcore runtimes. And they're probably making it such that so this can be an AWS runtime, and this could be a different runtime running something else. So that's probably the intention, which is good because okay, that's done. I'm going to check the status of that, and it looks like it's ready. That's the blog agent. Okay, export and save outputs. Gee, all these things are being run and stored. And the reason why we're storing these things is because the next notebook kernel startup is going to use those values. So, okay, so now we're storing these ARNs in the SS, in the parameter store, in the secret manager, wherever it needs to get stored. Here it goes in the parameter store, and it's done. And now we're invoking A2A agents. Let's refresh the auth token. Let's get the agent cards. Did this run? So this is fetch agent card. So that is the agent. Default option agent AWS docs. Let's look at the blogs agent. So there's this concept of cards where it's a standard way to document the agent. What this code did, it defined the fetch agent cards, and it used the session ID. Notice that's interesting. It used the bearer token, the session ID, and I got you two cards. Now it's testing the agents. Let's invoke the first agent using A2A. So if you look at this code here, let's just take a look at it real quick. Format agent response, create the message, send the message. Let's execute it. This is just formatting the response. This is creating the message, user role. Send sync message. Let's get the authorization token. Okay, let's just run it. Okay, so this is what it did. This is what it did, right? It sent this message, what is DynamoDB? And it has a response in the result. And basically, this particular one asks for the latest published blogs. Now, what the heck happened here? So I'm going to run this now because it was asking what is DynamoDB, and here it gives you an answer. It's a fully managed NoSQL database offering millisecond latency. Now we tested this, and it showed us what was the results. Here are the latest blog posts on Bedrock. Make agents a reality. Let's see this here. Now this is a more detailed output showing the steps that the agent has taken. So let's run this. So look at this, the agent execution trace. We have the agent execution trace. What is DynamoDB? Agent has these tokens it's processing. Agent is responding. Final result. DynamoDB is a fully managed NoSQL database. Okay, so basically, I know this video is getting long, but basically what we did in this video is we ran this notebook, which created the two agents. So if you go up here, that's really what the architecture was telling us. You're going to do this red box here now. First, we create this agent with tools, and we deploy the Agentcore. We take this agent with tools, we deploy the Agentcore, and now we're going to focus on this. In the next video, let's go look at this. Okay, we'll be right back.